Hey, I'm Chris Ralph, the professional prospector, and today we're talking about prospecting for copper ore, but we're going on part 2. Now, I had originally intended the prospecting video for copper to just be one video, but it got to be so full of so much information that I decided to break it into 2. So today, we want to talk about just why would you be interested in prospecting for copper? Well, copper is a very valuable metal. It's not as valuable as silver or gold, of course, but it's essential to our everyday life, the life that we live in a modern society. And if we didn't have copper, we would be living like it was 1500, you know. So it's incredibly important, and the truth is, it's considered the green metal. I mean, literally, for solar power, you need copper. For wind power, you need copper. For wires and electric power in developing countries, you need copper. For electric vehicles, you need a lot of copper. It's just one of these things where our world is going to need a lot of copper. And most of the mines that produce copper these days are old, big, huge mines that every year the grade gets lower and lower and lower, and it's hard for them to keep up with the demand. And in fact, experts are predicting that we are seeing now, and we'll see more in the future, more demand for copper than can be produced, and that's going to lead to high prices for copper. And so that's why I've come to you and brought these 2 videos to talk about how you can prospect for copper ores. Now, we're going to be focusing first. We're going to have several different segments. Oh, and one of the things I want to be sure to say is that stick around to the end of the video. I'm going to tell you a secret thing that not many people know about copper ores, and I'm going to tell you a little story about how that works and how you might be able to find some really valuable copper deposits that have been overlooked if you know this secret. So, we're going to start off with what ores look like in the field. Now, in part 1, if you guys haven't seen that, you should go back and watch part 1 of our prospecting for copper, because in part 1, I show you all different kinds of copper minerals, both oxidized minerals, minerals that have been subject to weathering, air, and water, and then the sulfide minerals. These are the original minerals that form deep down within the earth. So we talk about recognizing copper minerals. Now we're going to talk about what to look for in the field, what real ores with mixed minerals look like, and that kind of stuff, and what you might see if you were out in the field. After we talk about this, we're going to talk about the geology of copper deposits. We're going to talk about some of the different geologic types and environments that lead to copper deposits. And then finally, we're going to talk about the little secret that I mentioned. We're talking about enrichment of copper ore, and how the normal weathering process works with copper ores. And then we're going to sum it all up. So stick with me today, and let's get started right now on taking a look at what copper ores look like in the field.
Let's talk about what you'd see if you were to go out prospecting for copper. Now, this is an outcrop at an old copper mine, something that hasn't been worked since the early 1900s, so a little over 100 years since anybody's worked here. But you can see the blues and greens and yellow greens in the outcrop of the rock in front of the guy there. And this is what you might see at a copper mine if you were to go visit and do some prospecting, or if you were out in the field and you came across an outcrop of copper-bearing rock. This is the kind of thing that is what ore really looks like. So this is a typical outcrop of copper-bearing rock. Here's another example. You can see the blues and the greens. This is chrysocolla and malachite outcropping at a little old copper mine. I think this might be in Arizona. Anyway, it's a typical thing that you might see if you were visiting an area where there was copper ore around that could be found. Now a close-up of some typical mixed copper ores. This is pretty much mostly chrysocolla, but if you were to look at it real closely, there's some green staining in there from malachite, and this is just the kind of rock that you might see that's been infused with copper minerals. This is a super rich example, but this is a chunk of ore that was taken from, I think, the Bisbee mine in Arizona, and it's mostly azurite. You can see that's the darker blue, but there, if you look around, there's some greens, the brownish kind of rust-colored material is iron oxides, so there's a little bit of that too, but it's just a mixture of different things, but this screams really high-grade copper. On the other hand, you know, this is a close-up of something you might see in a typical hand sample that you would pick up. You see the dark blues of azurite, you see the greens of malachite, and then you see the rust color of iron oxides. Basically, the iron oxides are produced by the oxidation of pyrite, and the greens and blues are produced by the oxidation of copper sulfides. And this is basically a shot of some typical enriched copper ore from a porphyry deposit. Actually, this is from Nevada, but there are lots of porphyry deposits around the western United States and elsewhere in the world. And this is, you know, the typical, again, you see the green and blues, and it's mostly concentrated on the fractures because this is an oxidized ore. And so as the copper minerals were attacked by oxygen and water, the copper was released, and it went down various cracks in the rock and filled those spaces, and so that's why you see the mineralization is concentrated in the cracks. Now, if you're looking at sulfide ores, you know, you'd expect to see a mixture of things, and in this, the gold-colored mineral is the chalcopyrite, which is a copper pyrite. And then you see the iridescent blues and purples and a little green in there. That is your bornite, your peacock copper ore. So this is a rich specimen of copper ore. The white, of course, is quartz, but it's a mix. This is a typical kind of chalcopyrite rich ore. You can see the gold color. That's the chalcopyrite that's been deposited in the rock. The little part with the green down at the lower right hand side is actually a different specimen that was slightly in front of the other one. So it's not the same chunk of rock. But this is a typical sulfide type copper ore that you might see out in the field if you were looking in and around an old copper mine that got into the sulfide zone. And here's another typical mixed copper and rock, other things that you might see. And you know, ore like this will run several % copper, which is considered pretty darn high grade these days. A lot of big copper mines operate on only, you know, less than 1%. A lot of them, some are closer to 0.5% copper, and that can be mined profitably. So these are some typical looking copper ores that you've seen here, and you can keep that in mind when you're out in the field.
Okay, now that we've talked a little bit about what you might see in the field, let's dive into the geologic formations that create copper ores. You see, copper doesn't just form randomly out in the middle of nowhere. It forms when a certain set of geologic conditions come together, and then that creates, allows the formation of copper ore and copper minerals. So we're going to talk about those geologic formations, the different kinds of copper deposits that are out there, maybe give some examples of some places where those copper deposits have been found, and we'll get into that right now.
One thing about copper deposits is that they tend to be just really huge. You can see by this big open pit mine, this is the Berkeley pit in Montana, And then there's another big copper mine. This is the big pit at Ely in Nevada. Copper mines tend to be gigantic and produce a lot of copper. So they're widespread, and knowing a little bit about how they form and the geology that forms them is important. The first group we're going to look at is the porphyry deposits, and that's what these are. Perhaps the largest and most productive types of copper deposits in the world are the porphyry types of deposits, and they occur in various areas all over the planet. There's a lot of them in Arizona, and quite a few, of course, even more in Chile, in South America. And they are very huge deposits. And actually, copper deposits, in order to be economic, need to be very large. Now, these porphyry deposits, let's take a look at the geology. Here's a slide, and what I'm showing with this is that the porphyry deposits are controlled and related to intrusions of what they call on this diagram a porphyry stock. That's a granitic type of rock, an intrusive rock, what geologists would call a felsic intrusive rock, that is intruded into older water-saturated rock. The hot rock coming into contact with the older water-saturated rock causes the explosive generation of steam, fracturing both the intrusive rock and the surrounding country rock. The fracturing then allows hot mineralized fluids to circulate through the area and create the deposits. Now, skarn-type deposits are formed in a similar process, but are developed due to contact of the hot porphyry rock with the country rock in cases where the country rock has significant amounts of calcite or limestone. The acidic nature of the fluids that circulate in part dissolve away the limestone and open up space for new minerals to be deposited. As far as mineral deposits, the porphyry copper systems are characterized by chalcopyrite in stockwork veinlets and disseminated sulfide grains through the hydrothermally altered porphyry intrusives and in adjacent country rock. The systems are best developed in areas where the highest degree of fracturing took place. The ore material is often in the outer shell of the intrusion and the immediate area of country rock around it, because this is where the greatest level of fracturing would take place. Now, the porphyry skarn copper systems are characterized by chalcopyrite bearing quartz sulfide stockwork veinlets in porphyritic intrusive rock and adjacent skarn. Ore-grade copper mineralization in the skarns is usually found within about 200 feet of the contacts with the porphyry intrusive itself. There's a kind of a continuum between copper porphyry and copper skarn deposits. They can grade into one another. These systems don't just produce copper, they also produce other things, as is shown on my little diagram here, because I've also shown how they're related to polymetallic replacement type silver, lead, zinc deposits. They can be related to, you can see dikes of the porphyry material. I colored the porphyry material this blue kind of color, and dikes that are intruded along faults can give rise to these polymetallic replacement types of systems. And these are found in many places throughout the West. Similar dikes and intruded along faults can also give rise to what's noted on this diagram as a distal disseminated gold-silver. And these can be actually quite large. The distal disseminated deposits, there's a couple of them in Nevada that have produced literally millions of ounces of gold, in addition to small amounts of copper. This diagram shows how the skarns, which I've colored green here, are related to the contact of the intrusive rock, here shown as kind of a pink tan igneous intrusion, and then the surrounding country rock, the older rock that the intrusion was pushed into. In this diagram, they actually show the intrusion getting up almost to the surface and having a kind of a steam emission or a volcanic eruption or something like that, but that's not always the case. But the skarn forms at this contact zone where the heat and the acid leaching of the rock on the boundary with the igneous intrusion causes mineralization to be created. The next type we're going to talk about are the volcanogenic massive sulfides. And what I have pictured here is what's called a black smoker. It's only been in the last, 40 or 50 years that these things have been discovered in various places on the ocean floor. They emit this black smoke. They're usually way down deep, but you can see the surrounding area is dark. It's because once you get down to the ocean floor in deep areas, it's dark. And so these vents emit this black smoke. Well, the black smoke, and there's also normally some very weird forms of life that are living down here, but this black smoke is actually mineral. It's basically consists of sulfide minerals, mostly pyrite, but often lots of zinc sulfides and lead sulfides, and of course chalcopyrite, the copper iron sulfide. And so these vents, they operate for millions and millions of years, and over long periods of time this smoke settles out in, the particles are coarse enough that it settles out. You can kind of see some of the black material on the ocean floor just behind the smoking vent. It settles out to form a deposit. And here's a diagram of how that basically is set up. Underneath, deep down, there's a magma, basically molten rock, that's come close to the surface. And you have a fracture zone caused by faulting. And so the ocean water circulates down through the rock, is heated by the magma, and then comes up. And as it travels, it captures minerals out of the rock, and that's what comes out of the black smoker. And as it continues over long periods of time and material builds up, you end up with basically a mound of material. The mound is centered on where the vent used to be. Sometimes there are a series of vents, and so it isn't a single mound like this, but this is a kind of an idealized diagram. And over time, the minerals that are emitted usually change, and in the early and central hottest type of period, you get chalcopyrite and pyrite, so you get the copper rich is the oldest and most central. And then as time goes by, it will tend to change over to more, it says pyrite, sphalerite, and galena. That's basically iron with zinc and lead. And then in the final phase, you still have the zinc and lead, but you also add a Ba, which is barite. And then there actually are such a thing as a white smoker. And in white smokers, you don't get the metallic minerals coming out, the sulfides. Instead, you're just getting the barite coming up through the smoke. And so it's kind of the last stages of these black smokers. But because they operate for such a long time, and this is really not an unusual situation, they create some very significant deposits. These things are mined around the world for, of course, copper, but also zinc and lead, and even to a lesser extent for silver and gold, because there's also a certain amount of silver and gold in these, and sometimes other metals like cobalt. So they're an important source of minerals, and then, it's on the ocean floor. Eventually it gets buried with other lava or other rocks, other sedimentary rock, and it may get pushed up onto the continent, onto the land, and then it becomes a mineral deposit which gets mined. And these are important sources of metal. And the kind of rocks that are associated with them are almost always basalts and other volcanic rocks. You can have diabase dikes, which is basically a basalt that cooled a little bit more slowly, so it formed visible crystals. They're very common and been mined for copper in a lot of places. The Duckwater area of Tennessee was an important source of copper. That's the kind of deposit it is. There are several in California that were mined. There's a couple in Nevada. So, the Jerome district in Arizona was one of these types of deposits. So that's your volcanogenic massive sulfide. The next one I want to talk about is what's called redbed, or stratabound disseminated copper sulfides in reduced beds of sedimentary rock. These are kind of interesting because they're formed after the host sediments are deposited, but in most cases prior to the sediments turning into solid rock. They form independent of any igneous processes, so no magma or intrusive rock is involved directly in these. Now they do have to have a independent or outside source of copper, and in some cases people think that older porphyry deposits, as the copper was leached off them as they eroded, then the copper went down into these basins and was eventually formed into these types of deposits. It involves a reducing environment with usually a fairly acidic type of environment, such as marine black shales, fossil wood, or ancient algae mats. What happens is biogenic sulfides and pyrite in the sedimentary rocks will react with the copper-bearing liquids that are flowing through there, and often underneath there's an impervious layer which allows the copper liquid to circulate through there, and then the reaction with the algae or the other sulfur in the bed reacts to form chalcocite, which is the chief ore mineral of these types of deposits. And they're important in various places around the world. The last one we're going to take a look at in our survey of important economic geology type copper deposits is the iron oxide copper gold deposit. And this is kind of something new. They've only been recognized as a unique deposit in the last few decades. Now they're similar in some ways to porphyry, and that's why this diagram was drawn up, was basically to compare your normal porphyry copper deposit to the iron oxide copper gold type of deposit. Both are formed when an intrusive rock is inserted into older rocks, and the older rocks, because of the contact with the really hot intrusive magma, forms basically a flash steam event that explodes through the rock and fractures it. And that's kind of what they've drawn with all the little red lines going different directions. These are intended to be like the fractures that are formed by the explosive generation of steam. Now in the porphyry type of example, the magmatic fluid rich in sulfur dominates, and so you get all the iron is deposited as pyrite, and then you get, of course, other pyrite or sulfide minerals like chalcopyrite. And on the surface, you might get, above it, you might get a high sulfidation type of epithermal system, or advanced argillic alteration, which is a sign of very acidic fluids. That's what you'd get in your porphyry related. Now in the iron oxide copper gold, the groundwater is oxygenated, and there's enough groundwater that it dominates over the magmatic fluid. In the porphyry, the magmatic fluid rich in sulfur dominates. In the iron oxide copper gold, oxygenated groundwater dominates, and so you get you don't get the sulfide minerals as much. You get maybe a little bit, but you get much more commonly oxide minerals like hematite and magnetite. Hematite and magnetite are both iron oxides. But you get other minerals, and you tend to get oxides and very fine-grained minerals. So the key to the formation of iron oxide copper gold deposits is that abundance of oxidized groundwater in the country rock that will mix with the magmatic water from the intrusion, but it'll dominate. And the high oxygenated environment means that you get different minerals formed. But you can see in theory that they're fairly similar. And so geologists are keeping an eye out for these iron oxide copper gold deposits because they're kind of something new that hasn't been looked at as much.
So we talked about the different geologic environments and types of copper deposits there are that get mined. I want to promise you that I would delve into a little secret about copper, and we're going to talk about that right now: copper enrichment and actually also copper depletion. You see, the formation of those bright, brilliant blue and green oxidized copper minerals like we talked about in part 1, those form by weathering, by oxygen. And what happens is they are literally leached down from the surface and deposit a little bit below the surface, and thereby enriching the ore down below. And sometimes the ore down below can be super rich, as we saw in the part where I was talking about what you might see in the field. But what happens with that process is the surface where it leaches down from actually becomes depleted. And so you might see a situation where on the surface there was very little copper and didn't look like much of anything. And yet down below there would be a lot of copper. I got a great story about that. I'm going to tell it to you right now.
So finally I want to get to the point of why I say that copper is worth prospecting for, to tell you my little secret about why there's probably a lot of important copper deposits out there that have yet to be discovered, and tell you a little interesting story about a guy who prospected in Nevada and struck it rich. Now, the story of this that you need to know beforehand is that rain and oxygen from the air will act on copper sulfide minerals, and literally the oxygen and the water turn the sulfur in the sulfide minerals into sulfuric acid. And the sulfuric acid will bleach the rock, but it'll also dissolve the pyrite and it'll dissolve the chalcopyrite. Now the iron usually ends up just as rust, as iron oxides, but the copper is leached downward, usually staying inside the vein or inside the deposit, and it forms an enriched oxide zone, and below that are enriched sulfide zone. And I've kind of talked about that a little bit, but this graph shows how that works, how the rainwater leaches down and it forms enriched rich copper oxides, and then below that rich copper sulfides. But the trick of this is that the gossan, the top part, is usually just iron oxides and quartz, and will have very little or almost no copper at all. And so it doesn't look like much. Some of the other pictures I showed you in what field inspections of copper deposits would look like, you could see the nice copper ore, but in a lot of gossans like this, they'll be nearly barren, and you'll have to go down below to reach this enriched zone before you really start hitting good copper. And that's just how it works, and that's why I think that there's a lot of these barren gossans, not everyone certainly, but there's a lot of them out there that may hold some really rich copper deposits below them, because the copper that was originally there in the vein at what's the surface now has been washed downward and redeposited. Let me show you something here. This is a sample of the outcrop of the Rio Tinto Orebody. Now you can see this, there's a few little flecks of green, and that is copper, but if you were to have this tested chemically, it would be a very low-grade copper deposit. In fact, too low to bother with mining. So there's an interesting story that goes with this. You see, just about 100 years ago, in 1919, a prospector in Nevada staked some claims beneath an unusual barren gossan, this iron-stained rock that he found on an old prospect on a little prospect dump near Mountain City, Nevada, in the eastern part of the state. Now, the guy, his name was Frank Hunt, and he was a prospector, kind of geologist. He had maybe a year's worth of formal training beyond high school, and he was interested in finding metallic ores, and he prospected in western Utah and eastern Nevada for about 35 years. The problem was is that Nevada, and Utah too, have been explored thoroughly over the years, and a lot of people have been out there looking for gold and silver and copper and zinc and other metals. And so he found this unusual barren gossan material with just a few flecks of copper in it, and he had a good feeling about it. So he did some work, and eventually he started to sink a shaft down to see what the deposit might look like further down. It didn't look very good on the surface, as you can see from these samples, but he thought maybe it would get better. Well, it took years for him to sink, because he would sink his shaft down another 20 or 30 feet, and he'd run out of money, or the weather would turn to snow, and he'd have to head back to town and get a job and put together a grub stake for himself, and then when he had some money in the spring, he'd go back out and he'd sink his shaft another 10 or 20 feet or whatever he had money to do, and then he'd have to go back. Eventually, but he stuck with it. That's the key. He really stuck with it, and he stuck with it for 13 years. After about 10 years, he had a lawyer help him to set up a little bit better way of raising some money other than working and getting himself a grub stake. He also had the opportunity to go around and sell stock. Now, you can't do that these days, but back then it wasn't illegal. And so he would go to the towns and the people that he knew in the towns, and he would sell them shares in his mining company for 5 or 10 cents a share. And then he would gather that money up and use it to sink his shaft a little further. Well, finally, in 1932, when he was actually 68 years old, so he was no spring chicken, and he'd been at this for decades, he finally got his shaft down a whopping 218 feet. Now imagine the amount of work that he'd done over 13 years to sink a shaft down by himself mostly, although toward the latter, when he had a little more money, he would hire some helpers to sink it down 218 feet. Well, when he got down that depth, he still was optimistic, and suddenly the iron-stained gossan gave way to super high-grade copper ore. It was an amazing sight, and his very first samples measured almost 50% copper by weight. Here is a sample of the high-grade ore that he hit into. The green is malachite, the dark is chalcocite, super rich copper ore. This sample here would run better than 50% copper. Well, he sold out to Anaconda, which was a big famous copper mining company, and literally by the age of 68, Frank Hunt, who was, a poor prospector miner working out by himself mostly in the deserts of Nevada, was suddenly a multi-millionaire. The people who had bought stock from him for 5 or 10 cents a share, that stock went up to over $17 per share. Some of them had, figuring that the shares were worthless, had thrown the paper away, and there was no other record other than the papers that he had given them. The mine operated for 15 years, mostly through the World War II period, when the needs for copper were very high, and the mine ended up yielding 216 million pounds of copper metal, 304,000 ounces of silver, and 6,300 ounces of gold. The ore was very high grade, and it was just an amazing find. It was made because Frank stuck to it. He knew enough, like I say, he had about a year's formal education beyond his high school, and he knew enough about geology that this outcrop looked different to him, and sure enough, it really was different. So that's my thing that I want to say about surface enrichment, because the surface is actually often depleted, and the copper is leached down to an enriched zone. Now sometimes that enriched zone may only be 30 feet or 50 feet below the surface. Sometimes, as Frank found, it's over 200 feet. But the old records from Frank's work showed that it transitioned between the barren gossan to the copper enriched zone in no more than about a foot. So at 217 feet, he was still in the junk. And at 219 feet, he was in rich ore. So that's something to remember when you're out prospecting for copper, is that there's a lot of copper deposits that haven't been found because the surface exposures have been leached. They may look something like this, but down below may be super rich ores like this. And there's also enriched oxidized copper. I mentioned that there's an enriched oxidized zone, and then below that an enriched sulfide zone. And so these are examples of why it's important to really stick to your prospecting for copper, and I hope that you have the same kind of luck that Frank had, and that you stick to it. He worked very hard. He certainly earned it in the 13 years that he stuck with his little claim up there by Mountain City, Nevada. In the end, though, he was a multimillionaire. So there's a lot of potential with copper. Copper can be very rich, and it can be really important, and certainly it's a necessary mineral, necessary metal for our modern way of life.
Now, if you've been on many of my videos, if you've seen many of my videos, you know that I'm into prospecting and finding minerals, gemstones, mostly gold, sometimes silver, sometimes other things like copper, and I'm into that kind of stuff. And if you have any interest in finding gold for yourself, because hey, there's gold out there to be found, and my videos prove that. If you're interested in finding gold for yourself, then you might want to see my book. It's called Fistful of Gold, because that's what I want you to find. And I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold, and I wrote it because I want you to be able to go out and find for yourself fistful of gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below, but there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts, and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if again you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.